You read all these questions. A and B are complex numbers. Minimum value of AB bar plus A bar B by mod AB. That is our question. You call Z is equal to AB bar. What is Z bar? A bar B. Correct. Z is equal to AB bar. Z bar is equal to A bar B. Now, AB bar plus A bar B is equal to Z plus Z bar. Correct? Is it not? Now, you should remember one point. For any Z, Z plus Z bar by 2 is equal to real part of Z. And real part of Z is always less than or equal to mod Z. See, if Z is x plus iy, real part of Z is x. Mod Z is what? Root of x square plus y square. X is definitely less than or equal to root of x square plus y square. This is obvious. X is definitely less than or equal to root of x square plus y square. That's what I wrote. So, you remember this point. So, Z plus Z bar is equal to 2 times real part of Z, which is less than or equal to 2 mod Z. Correct? So, finally you got AB bar, A bar B less than or equal to 2 mod Z. AB bar plus A bar B by mod Z less than or equal to 2. So AB bar plus A bar B by mod Z is what? Mod AB. Mod AB or mod AB bar both are one and the same. Less than or equal to 2. So therefore maximum value, I think it should be maximum, not minimum. Maximize it. Not minimum, maximum. So maximum value of this is 2. You can do like this. Okay, just watch this problem. Yes, it should be maximum only. A and B are complex. Find the maximum value of AB bar plus A bar B by mod AB. See, mod Z is mod AB bar. Mod AB bar is as good as mod A bar B, which is also mod AB. Mod AB bar is mod A into mod B bar. Mod B bar is as good as mod B. Therefore, I can write like this. So that is a very important question. Next question is Z minus 2 by Z is equal to I tan argument of Z. What is the locus of Z? Now listen, you can call Z is equal to x plus n. Argument of Z is equal to tan inverse imaginary part by real part. Is not tan theta is argument means tan theta is what? Y by x. Y is imaginary part. X is real part. So argument of Z is this. So what you are going to get? X minus 2 plus iy by x plus iy is equal to I tan of tan inverse y by x. Correct? You will get like this. So x minus 2 plus iy by x plus iy is equal to I into y by x. Understood? So now this is purely imaginary. So real part is 0. So you can consider like this: x minus 2 plus iy into conjugate of this x minus iy by x square plus y square is equal to I into y by x. So what is the real part? This into this. So x into x minus 2. This into this means plus y square by x square plus y square is equal to 0. So real part is this. And what is imaginary part? X minus 2 into this, minus y into x minus 2 plus xy by x square plus y square is equal to y by x. So this will give you, if you cross multiply, I am writing here, x square plus y square minus 2x is equal to 0. So this is this. So this is what? Circle. That's what I said. It is a circle. Center is what? 1, 0. And what about this? We can cancel throughout y above. You will get minus x plus 2 plus x by x square plus y square is 1 by x. X will cancel. So finally you will get what? X square plus y square minus 2x is 0. Same as this. So therefore, the locus is what? Circle with center at 1, 0. Will it pass through origin? Yes, origin satisfies this. It also passes through origin. Z1 and Z2 satisfy one equation. Real part of Z is equal to mod Z minus 2. Argument of Z1 minus Z2 is pi by 3. Then what is imaginary part of Z1 plus Z2? This is a very, very important question. Just watch. See, first of all, if I call Z is equal to x plus iy, real part of Z is x is equal to mod of x plus iy minus 2. So x is equal to this. So x is equal to mod of x minus 2 plus iy like this. You square it. X square is equal to mod of this square is real part square plus imaginary part square. So when you simplify this, x square is equal to x square minus 4x plus 4 plus y square. So finally you will get y square is equal to 4x minus 4. So this represents this curve in the Cartesian form. You will be knowing this in parabola. This is parabola equation. So apparently you did not know about anything about parabola. But in parabola, you will be noticing that this is a parabola equation. Now, Z1 and Z2 satisfy this equation. I will call Z1 as x1 plus iy1, Z2 as x2 plus iy2. So x1, y1 has to satisfy this. So because of this, you will get y1 square is equal to 4x1 minus 4. Because of this, you will get y2 square is equal to 4x2 minus 4. What is y1 square minus y2 square? 4 into x1 minus x2. Shall I put it like this? y1 minus y2 by x1 minus x2 is equal to 4 by y1 plus y2. I am factorizing this. y1 minus y2 into y1 plus y2. 1 y1 plus y2 I am sending here. x1 minus x2 I am putting here. So y1 minus y2 by x1 minus x2 is equal to 4 by y1 plus y2 you will get. You keep this as equation number 2 like this. Next. What else is given? Argument of Z1 minus Z2 is equal to pi by 3. So argument of Z1, you write it x1 minus x2 plus I into y1 minus y2 is equal to pi by 3. Argument of a complex number means tan inverse imaginary part by real part is equal to pi by 3. Argument of this pi by 3, this is this complex number. Argument of x1 minus x2 plus I into y1 minus y2 is tan inverse imaginary part by real part. So what is y1 minus y2 by x1 minus x2? Tan pi by 3. Tan 60 means root 3. So this value you put here. Then you are going to get root 3 is equal to 4 by y1 plus y2. So therefore what is y1 plus y2 finally? 4 by root 3. y1 plus y2 is nothing but imaginary part of z1 plus z2. z1 plus z2 is x1 plus x2 plus I into y1 plus y2. So y1 plus y2 is nothing but imaginary part of z1 plus z2. So imaginary part of z1 plus z2 is 4 by root 3. So first consider z is x plus iy. Real part of z is x. Mod of z minus 2 like this. You square it. X square is equal to mod of this square. Real part square plus imaginary part square, you write it, simplify this, you will get parabola equation like this. Z1 is this, Z2 is this. Z1 and Z2 satisfy this. Therefore, y1 square is equal to 4x1 minus 4. And y2 square is 4x2 minus 4, subtract one from the other, get up to this. Consider argument of z1 minus z3 pi by 3. Then write it like this, you will be through. See, to do the next question, you can call z is equal to x plus iy, mod z is equal to square root of x square plus y square, you can call it as r. You are having ln of r square plus 2r plus 4 by 2r square plus 1 greater than 0. E is greater than 1. So if you remove log, inequality remains same. R square plus 2r plus 4 greater than by 2r square plus 1 greater than 1 will get. You send it to that side. R square plus 2r plus 4 greater than 2r square plus 1. Finally, r square minus 2r minus 3 less than 0. R minus 3 into r plus 1 less than 0. R is less than minus 1, R is greater than, sorry. R value should lie between minus 1 to 3. Right. Okay. But R is always greater than 0. Mod is always not greater than or equal to 0. So R value should lie between like this. R square value lies between what? Like this. What is R square? X square plus Y square. So 0 less than or equal to x square plus y square less than or equal to 9. So this is the locus, less than. This is your locus. Find z common to argument of z minus 2 is equal to pi by 3 and argument of z plus 3i is equal to 2 pi by 3. This is our first question. See, first we have to calculate what is argument of z minus 2 is equal to pi by 3. You put z is equal to x plus iy. Z minus 2 is equal to x minus 2 plus iy. Now, argument of z minus 2 is equal to tan inverse y by x minus 2. Correct? Tan inverse imaginary part by real part. Now listen. Argument of z minus 2 is equal to pi by 3 implies tan inverse y by x minus 2 is equal to pi by 3. Now, this is not enough. You should write some more conditions. What are they? Argument is pi by 3 means this complex number has to lie in the first quadrant. Argument is less than 90, first quadrant. lies between 90 and 180, second quadrant. Argument is negative, lies between minus 90 to 0 means fourth quadrant. Argument is negative, lies between minus 180 to minus 90 means third quadrant. So this is pi by 3. So this complex number lies in the first quadrant. When a complex number lies in the first quadrant, real part must be greater than 0. Imaginary part must be greater than 0. So you have to put these conditions also. It is not enough if you write like this. Now send tan to that side. You will get y by x minus 2 is equal to tan 60. So you will get y is equal to root 3x minus 2 root 3. Understood? So this is your argument of z minus 2 is equal to pi by 3 locus. So this locus is what? Straight line, but it is not a complete straight line. X value must be greater than 2. So somewhere here 2 will be there and y value greater than 0. Therefore, this line equation, how does it look like? When I put y0, x value how much? No, it starts with here only, no problem. When x is 2, y is 0. So this line will be like this. It starts with 2. So this is not a full line, it is a ray starting from 2, 0. X value greater than 2, y is positive only. So this is the line. This is the ray. It is not a complete straight line. You should remember, this is not a complete straight line. It is a ray starting from the point 2, 0. Now you take the other one. Argument of z plus 3i means argument of, shall I write directly? I into y plus 3 is equal to 2 pi by 3. So tan inverse y plus 3 by x is equal to 2 pi by 3, x greater than 0, y plus 3 greater than 0. So x greater than 0, y greater than minus 3. So therefore what you will get? Y plus 3 by x is equal to tan of 2 pi by 3 means tan of 120 degrees means you will get minus root 3. Correct? So you are going to get finally y is equal to minus root 3x minus 3 subjected to the condition x greater than 0, y greater than minus 3. So this is your equation 1, this is your equation 2. So this is your 1. You plot this. X is greater than 0, y is greater than minus 3. So minus 3 will be somewhere here. X must be greater than 0. Correct? X must be greater than 0 means this side. Y is greater than minus 3 means this side. When you plot this, when you put y minus 3, x value how much? 0. This. Okay, understood? Now, if you plot that, how does the line will look like? The line will be, how does it look like? The line will be like this, correct? Oh, sorry. This point coordinates are minus 3, 0. You put y0. When y0, x value how much? Correct. Oh, sorry. 2 pi by 3 means which quadrant? Second quadrant. In second quadrant, x is negative. X is negative, y is positive, right? Okay, x is negative. So, how does it look like? The graph will be like this. Watch. You plot this under these circumstances. Remember, tan inverse y plus 3y(x) is equal to 2 pi by 3. 2 pi by 3 is more than 90, less than 180. So, real part is negative, imaginary part is positive. So, put like this. So, the graph, if you plot, it will be like this. Now, in order to have a common complex number for both, that common complex number has to satisfy this ray equation, this ray equation. Is it possible? No. So one ray is like this, other ray is like this, they never intersect. See, if we consider full lines, they will intersect, but there is not, the locus is not a full line, it is a ray starting from this point and this point. So, the common point for the equations 1 and 2 does not exist. Therefore, the common complex number Z satisfying both equations does not exist. So, Z does not exist is your final answer. I think you follow the analysis of the problem. What you are supposed to do when you come across a problem like this. See, argument is tan inverse imaginary part by real part. There is no doubt. But depending upon its value, you have to put two more inequations. Argument is between 0 and 90 means imaginary part positive, real part positive. Argument is between 90 and 180 means real part is negative, second quadrant, real part is negative, imaginary part is positive. Like that you have to put and assess the problem. Okay, understood? So the next question is, A is a complex number, mod A is equal to 1, AZ square plus Z plus 1 is equal to 0 has purely imaginary root. What is tan argument of A? You imagine A is equal to cos theta plus I sin theta because mod A is 1. Let us say AZ square plus Z plus 1 has purely imaginary root means let Z is equal to Ki. Z is equal to Ki. Then what you are going to get? Cos theta plus I sin theta into K square I square plus Ki plus 1 is 0. So I square is minus 1. So what is the real part in this? K square cos theta, right? K square minus K square cos theta plus 1. Plus I into K minus sin theta is equal to 0. Correct. K square is minus 1. Right? So minus I sin theta minus K square sin theta. Okay? K square sin theta minus 1. I into K. This is 1. So this is 0 means K square cos theta is equal to 1. K minus K square sin theta is 0. This must be 0. This must be 0 like this. Okay, alright. Now K cannot be 0 because it is purely imaginary. So what will be your K value for you? 1 by sin theta. Correct. You substitute here. You will get cos theta by sin squared theta is equal to 1. So cos theta is equal to 1 minus cos squared theta. So cos squared theta plus cos theta minus 1 is 0. So what is cos theta for you? Minus 1 plus or minus 1 plus 4 by 2. So this is as good as 1 plus minus 1 plus root 5 by 2. Cos theta is equal to root 5 minus 1 by 2. Remember, minus 1 minus root 5 by 2 is less than minus 2. Cos theta cannot be less than minus 1. Therefore, you have to consider only positive value. When cos theta is like this, how to calculate tan theta? This is theta. This is root 5 minus 1. This is 2. What will be this? Square root of 4 minus 5 minus 1 plus 2 root 5. Right? So this will be equivalent to 2 root 5 minus 2. 2 root 5 minus 2. So this is square root of 2 into root 5 minus 1. So square root of 2 into root 5 minus 1 like this. Therefore, what is tan theta? Square root of 2 into root 5 minus 1 by root 5 minus 1. Root 2 by root of this. Okay, what you require? What you require? Tan of argument of A. Argument of A is what? Tan inverse root 2 by root of root 5 minus 1, which is root of 2 by root 5 minus 1. If you want, you can rationalize this. 2 into root 5 plus 1 by 5 minus 1. So, root of root 5 plus 1 by 2. So, that is your tan of argument of A. Right? So, the procedure is very simple. Listen. You can call A is equal to cos theta plus I sin theta. The equation is having purely imaginary root. Let us say Z is equal to Ki form. Substitute, segregate real part, segregate imaginary part. Real part is 0, imaginary part is 0, you put it. Here you will get K value 1 by sin theta, eliminate K. You will get a trigonometric equation. I converted sin in terms of cos and I solved for the equation. I have taken only root 5 minus 1 by 2. Why root 5 minus 1 by 2? Because minus 1 minus root 5 by 2 cannot be valid answer for cos theta. So that's why I chosen only plus. After getting cos theta to this, you know how to calculate. Then I calculated tan theta. Then you require tan of argument of A. Argument of A is theta. That is tan inverse of this. So which can be estimated like this. Just cross the problem. The next question is mod of Z1 minus Z2 whole square is equal to mod Z1 square plus mod Z2 square. What is argument of Z2 by Z1? You can consider Z1 is equal to R1 into cos theta 1 plus I sin theta 1. Z2 is equal to R2 into cos theta 2 plus I sin theta 2. Z1 minus Z2. R1 cos theta 1 minus R2 cos theta 2 plus I into R1 sin theta 1 minus R2 sin theta 2. Mod of Z1 minus Z2 whole square means real part square plus imaginary part square. R1 cos theta 1, R2 cos theta 2 whole square. R1 sin theta 1 minus R2 sin theta 2 whole square. This is, when you expand R1 square, you will get R2 square minus 2 R1 R2 cos of theta 1 minus theta 2. So now you put that in that equation. R1 square, R2 square minus 2 R1 R2 cos of theta 1 minus theta 2 is equal to R1 square plus R2 square. So finally you are going to get cos of theta 1 minus theta 2 0. So theta 1 minus theta 2 is equal to plus or minus pi by 2. So argument of Z1 minus argument of Z2 is plus or minus pi by 2, which is nothing but argument of Z1 by Z2 is equal to plus or minus pi by 2. See, when argument of Z1 by Z2 plus or minus pi by 2, argument of Z2 by Z1 is also same. Therefore, mod of argument of Z2 by Z1 is equal to pi by 2. See, any problem like this is the procedure. Here are the discussion. Find locus of Z such that argument of Z minus of 3 plus 4i by Z minus of 6 plus 8i is equal to pi by 3. What is the locus of this? You should remember the following point. Argument of Z minus Z1 by Z minus Z2 means what? If you are having a complex number Z here, Z2 here, Z1 here. So this is as good as argument of Z1 minus Z by Z2 minus Z. So this vector is Z2 minus Z. This vector is Z1 minus Z. So this means angle measured from denominator vector to numerator vector in the anti-clockwise direction. Right? You recall this definition. Angle measured from denominator vector to numerator vector in the anti-clockwise direction. So this is the concept first you have to recall. After recalling this concept, this is as good as argument of 3 plus 4i minus Z by 6 plus 8i minus Z is equal to pi by 3. Right? Now, these are your coordinate axes. Somewhere here 3, 4 will be there. Somewhere here 6, 8 will be there. Now, you are measuring angle from this vector to this vector in the anti-clockwise direction. Somewhere here, let us say Z will be there. This is the vector, denominator vector. This is the numerator vector. So this angle is how much? Pi by 3. Right? So this is the situation for us. Now, listen. You consider a segment of the circle like this. A segment of the circle like this. So this is the full circle. Right? Now, if you join this chord, so this angle, this angle, this angle, this angle, all are what? Pi by 3. Therefore, all complex numbers Z satisfying this will lie on a arc of a circle. Will lie on what? Arc of a circle. For which this is the chord. AB is the chord. Understood? So the locus of Z will be what? Set of all points on the arc of a circle like this, for which AB is the chord. So this is pi by 3. Now somewhere here center of circle will be there. Let us say O is center of circle, or let us say P is center of the circle. You join to this. You join to this. If this is pi by 3, this is how much for you? 2 pi by 3. You all of you know this. Suppose if you are having a circle like this is the chord. If this angle is theta, angle subtended at the center is 2 theta. So like that, this chord is subtending pi by 3 at a point on the circumference like this. At the center it subtends how much? 2 pi by 3, double of this angle. Right? So basically Argument of this is equal to pi by 3 is not a full circle. It is the segment of the circle. The chord will determine that segment. The chord will subtend an angle of pi by 3. So set of all points in the xy plane at which the chord AB will subtend an angle pi by 3 is your locus of Z. Understood? Now the next point is, they will ask you to calculate length of this locus. Length of this locus, how to calculate is our question. Let us say this is R. This is also R, radius of the circle. Right? This is R, this is R. This is your 2 pi by 3. Now you can make use of cosine rule. AB square is equal to R square plus R square minus 2R square cos of 2 pi by 3 I can write. Cosine rule all of you know. This square is equal to this square plus this square minus 2 this into cos of 2 pi by 3. What is AB square? 9 plus 16 is equal to 2R square plus 2R square into 1 by 2. Cos 2 pi by 3 is minus half, cos 120. So 3R square is equal to 25. R square is equal to how much? 5 by R is equal to 5 by root 3. R is equal to 5 by root 3, you got it. Now, after getting R value, listen here. If this is 2 pi by 3, this is how much for you? 2 pi minus 2 pi by 3, which is 4 pi by 3 you will get. This is your 4 pi by 3. Now, this arc length is nothing but S is equal to R theta. So, arc length is equal to S is equal to R into theta in radians. You might have studied this in your 10th class. So, arc length is equal to, so length of locus is equal to S is equal to R into, this is theta. R is how much? 5 by root 3. Theta is how much? 4 pi by 3. So this will be 20 pi by 3 root 3. So length of locus of Z is given by 20 pi by 3 root 3 like this. So first of all, locus is not a full circle. Locus is what? A part of the circle. Right? Then usually in the examination they will ask you like this. Find length of locus of Z satisfying this. Means length of locus of Z means you are expected to calculate like this. If this is pi by 3, this is 2 pi by 3. This is R because radius of the circle. Then in this triangle you can apply cosine rule. AB square is equal to R square plus R square minus 2R square cos 2 pi by 3. Hence R value can be estimated. After knowing your R value, you have to calculate this length means S is equal to R theta you can apply. Here theta happens to be 4 pi by 3, therefore S is equal to R theta if you put, you are going to get 20 pi by 3 root 3 you are going to get. So this is where length of locus of Z satisfying this equation. See, the next question is, argument of Z is equal to theta. Theta is in the second quadrant. Mod Z minus 3i is equal to 3. Show that cot theta minus 6 pi Z is equal to I. So these are your coordinate axes. Mod Z minus 3i is equal to 3 means, I told you this point. Mod of Z minus Z1 is equal to R means locus of Z is a circle with the center at Z1. Radius is what? R. So what is center? 3i means 0, 3. Radius is also 3. So the circle will be like this, correct? it is a full circle. But what it says, Z is having argument between 0 and pi by 2. Means you should consider only on this side. So somewhere here Z will be there. This is O, this is A, let us say this is P. You join to this, let us say this is theta. You join to this. So this is 90 degrees angle in the semicircle. When this is theta, this is 90 minus theta, therefore this is theta. 90 minus theta plus 90 plus theta, like this. This is also 3, 6. Understood? You got like this. So this is where, this is the mod jet. This is your mod jet. Understood? So this is 6. So like this you are having. So what are your Z coordinates? Z is nothing but R into cos theta plus I sin theta. R into cos theta plus I sin theta is your Z. Okay, understood? R into cos theta plus I sin theta happens to be Z. Now, this is how much for you? 6. This is R. This will be square root of 36 minus R square. Correct. From this, what is cos theta? Cos theta is equal to square root of 36 minus R square by 6. Adjacent side by hypotenuse. What is sin theta? R by 6. Correct. You will get like this. So now, what you have to show? Cot theta minus 6. What is cot theta? Cot theta is equal to how much? Cot theta is equal to R by, cot theta is equal to, square root of 36 minus R square by R. This by this, cot theta. Now, you have to calculate 6 by Z. 6 by Z is equal to 6 by R into cos theta plus I sin theta, right? You can write like this. 6 by R into cos theta minus I sin theta. So you can rationalize this. You can multiply with cos theta minus I sin theta, will get like that. This is 6 by R into, what is cos theta? This root of 36 minus R square by 6. I into R by 6. Multiply this, you are going to get root of 36 minus R square by R minus I. Correct. You got like this. So what is your cos theta minus 6 by Z? Cos theta here, 6 by Z here. Substitute, you will get. You read on this questions. Number of solutions of the equation Z to the power of 2020 is equal to Z bar. This is our first question. See, Z power 2020 is equal to Z bar. Z is equal to 0 is a root. Correct. 0 definitely satisfies. Z is 0 plus 0i. Z bar is 0 plus 0i. 0 power 2020 is 0. So Z is equal to 0 is definitely a trivial solution. Definitely a solution. So this is number 1. Number 2, let Z not equal to 0. Then take mod on both sides. Mod Z power 2020 is equal to mod Z bar. Mod Z bar is equal to mod Z. So, mod z is equal to 1, correct? This implies mod z is equal to 1. So, mod z bar 2020 is mod z means mod z is equal to 1 is the root. We want z, but mod z is 1 you got. But mod z is how much? Z into z bar is equal to 1. So, mod z square is 1. Means z into z bar is 1. So, what is your z bar? 1 by z. Z bar is equal to 1 by z, you got it. Now, you take this equation. In the case 2. So, you are having z power 2020 is equal to z bar is equal to 1 by z. So, z power 2021 is equal to 1 you got. Listen, this is a equation having degree 2021. You all of you know this point, every nth degree equation will have n roots. So, this equation will have how many roots? 2021 roots. So, this will have 2021 roots. And already z is equal to 0 is a root. So 2021 roots plus this one root. This implies total roots are 2022 roots. So this equation will have 2022 roots. So z is equal to 0 is a root by inspection. Let z not equal to 0. Then you will get, if you take mod on both sides, you will get mod z is equal to 1. Z bar is 1. Z bar is 1 by z. So z power 2020 is 1 by z. Z power 2021 is equal to 1. Will have 2021 roots. Already this is having 2021 roots plus one more root. So total z power 2022 roots this equation will have. In general, z power n is equal to z bar will have how many roots? N plus 2 roots. Correct? Just like this. So z to the power of n is equal to z bar will have n plus 2 roots like this. Okay? Understood? Now the next question is, A, B, C are real numbers and unequal. He has given one equation. A plus B omega plus C omega square whole power 2021 is equal to A plus B omega square plus C omega. Then the value of A square plus B square plus C square minus AB minus BC minus CA is equal to how much? Where it is understood that omega and omega square are complex cube roots of anything. Here it is understood that omega and omega square happens to be complex cube roots of unity. You call z is equal to a plus b omega c omega square. What is z bar? A bar is a only. B bar is b. Omega bar is omega square. You recall, omega square are conjugate to each other. So omega bar is omega square. Omega square bar is omega plus c omega. So this equation is just like z power 2021 is equal to z bar. Correct. Now you take mod. Mod z power 2021 is mod z bar. And of course, z is not equal to 0 because if A, B, C are unequal, z can never be 0. If A, B, C are equal, then A you can take outside, you will get 1 plus omega square 0, therefore z not equal to 0. Take mod, you will get like this. From this is also what? Mod z. You will be getting mod z is equal to 1. So, mod z bar is mod z. Just like earlier problem, You can if you want to write one more step, mod z into mod z power 2020 minus 1 is 0. Mod z cannot be 0. So mod z whole power 2021 implies mod z is equal to 1. Z bar is also 1 per unit. Z bar is also 1 per unit. What is Z bar? A plus B omega C omega square into A plus B omega square plus C omega. You multiply this, you will get A square plus AB omega square AC omega multiplied with A, multiply with B, BA omega, BA omega, B square omega cube. Next, BC omega square plus, I write here, BC omega square. Next, you multiply with C. CA omega square. CA omega square. CA omega square. I put it below. AC omega square. Next, BC omega plus BC omega. Omega power 4 is omega plus C square. If I add all these things, you will get A square plus B square plus C square minus AB, because AB into omega square plus omega is minus 1, minus AC minus BC. So Z bar is equal to this. What is Z bar? 1. So this is all equivalent to how much? 1. Understood? So we call this as Z. Z power 2021 is Z bar form. You will get like this. Z can never be 0 because ABC are what? Unequal. So therefore, if you take mod on both sides, mod Z is equal to 1 you will get. Mod Z is Z bar is 1 you will get. Then you put it like this, multiply. This is nothing but your Z bar, mod Z square. So mod Z square is equal to 1 you got it. See, origin Z1, Z2 are vertices of an equilateral triangle, then find the condition. See, in the beginning, in one of our classes, I said this point. The necessary and sufficient condition for Z1, Z2, Z3 to be vertices of an equilateral triangle is Z1 square plus Z2 square plus Z3 square minus Z1, Z2 minus Z2, Z3 minus Z3, Z1 is equal to 0. That's what I said. So you write down that condition first once. Condition for Z1, Z2, Z3 to be vertices of equilateral triangle. Equilateral triangle. Z1 square, Z2 square, Z3 square minus Z1, Z2 minus Z2, Z3 minus Z3, Z1 is 0. Now, origin Z1, Z2, Z3. Origin Z1, Z2. Right. Z1 is 0, Z2 is Z1, Z3 is Z2. So, 0, Z1 square, Z2 square, 0, minus Z1, Z2, 0. So, condition is Z1 square, Z2 square minus Z1, Z2, 0. So, this is the condition for origin Z1, Z2 to form vertices of an equilateral triangle. So the next question is number of common roots. Common roots for Z power 15 is equal to 1. Z power 25 is equal to 1. Number of common roots for the two equations. This is our next question. Number of common roots for the two equations. See, you have to think like this. Z is equal to 1 power 1 by 15. So, cos of 2k pi by 15, I sin 2k pi by 15, k value 0, 1, 2, 3 up to 14. Then z is equal to 1 power 1 by 25. Cos of 2 lambda pi by 25. I sin 2 lambda pi by 25. Lambda is 0, 1, 2, 3 up to 24. Right? Where k will take all these integer values, lambda will take all integer values like this. Now, how many common roots are there? Means, for some value of k here, for some values of lambda here, both must be what? Equal. Means, I can put it like this. 2k pi by 15 is equal to 2 lambda pi by 25. So, k by lambda is equal to 3 by 5. So, k is to lambda is equal to 3 is to 5 we should get. K is to lambda is equal to 3 is to 5 we have to get it. Integer values. So, now you write neatly k values. K is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, up to 14. And lambda is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, like this. So, obviously, this is one common root. Then we should get 3 by 5. So, 3 by 5 means, which will give you 3 by 5 ratio? 3 is to 5. Right. Next, 3 by 5. 6 is to 10. 6 by 10. Right. Next, what you are going to get? 6 by 10. 3 is to 5. So, next ratio is 7 to 7 and that 8. 9. 9 is to 27. No, you will not get it. So, which will give you 3 by 5 ratio? You have to just go on doing it. So, first is what? 0, 3 by 5, 6 by 10. Next, 9 by 6 by 10 is 3 by 5, okay. Next, 6 by 10, okay. Then 9 by 15. 9 by 15. Then next 9 and next 4 and 12 by 12 by 20. 12 by 20. Next will be what? 12 next to 5 and 15. No. So 1, 2, 3, 4, 5. So there are 5 common roots for the two equations. So there are 5 common roots for the two equations. Understood? This is how you have to tackle the problem. See, you can easily tell by seeing this problem. The common roots must be in the form of what? The ratio of the arguments must be in the form of 15 by 25. 15 by 25 means how much you are going to get? 3 is to 5. Directly you can tell. I explained all these things like this. Now listen to one important point. When you consider z power p is equal to 1, z power q is equal to 1, if P comma Q are prime, if P comma Q are prime, you will never get common roots. If you want, you can try like this. You consider the equation z power 5 is equal to 1, z power 11 is equal to 1. These two equations will never have common roots because 5 and 11 are co-prime and 5 and 11 are prime numbers. So if P and Q are prime numbers, you can never have common roots for the two equations. Right? For example, you can find out. You consider this equation. Solve the equation z power 16 minus z power 5 minus z power 6 plus 1 is equal to 0. Solve this equation. You try this. So this is regarding the common roots of the two equations. The next one more important point to notice is, you consider one simple equation. Let us say z to the power of 6 is equal to 1. Then what are the roots of this equation? Cos of 2k pi by 6, I sin 2k pi by 6, k value ranges 0, 1, 2, 3, 4, 5 like this. See, when you plot all these roots, how do they look like? Zk is equal to 0 means you will get 1. K is equal to 1 means cos pi by 3, I sin pi by 3. See, modulus is 1 only. So this will be your pi by 3. Next, K is equal to 2 means what you are going to get? Cos 2 pi by 3, I sin 2 pi by 3. So you will be getting all the roots to lie on the circle like this. This is 1, right? This is, let us say, 1. This is alpha 1. Next, what will get? Cos 4 pi by. Next, k is equal to 2 and 4 pi by 2 pi by 3. So cos 2 pi by 3 means alpha 2. Next, k is equal to 3. K is equal to 3 means 9 pi by 3 like this. You are going to get alpha 3. Next you will get alpha 4. Next you are going to get alpha 5. So now this is A1, A2, A3, A4, A5, A6. So all the sixth roots of unity will be vertices of a regular hexagon like this. All the sixth roots of unity will be vertices of a regular hexagon. You can easily watch. Similarly, when you consider all the nth roots of unity, all the nth roots of unity will lie on a circle and they will be vertices of a regular polygon of n sides. A1, A2, A3, etc., etc., An. So nth roots of unity will be the vertices of a regular polygon of n sides. That's what I want to impress. You should notice by this time by writing all these things. So nth roots of unity will be vertices of a regular polygon of n sides like this. Okay, understood this point? So try to think all these points here. Sixth roots of unity will be sides of a regular hexagon. Sixth roots of unity will be vertices of a regular hexagon. Nth roots of unity will be vertices of a regular polygon of n sides. This is what you should remember. Okay. For any integer k, ak is equal to cos k pi by 7, I sin k pi by 7. You have to calculate this. Sigma is equal k is equal to 1 to 12. mod ak plus 1 minus ak. Sigma k is equal to 1 to 3 mod of a 4k minus 1 minus a 4k minus 2 is equal to how much? Now, listen. Your ak is nothing but, shall I put it like this, cos of 2k pi by 14 I sin 2k pi by 14. See, they are all nothing but what? 14th roots of unity. So all of them will form a regular polygon of 14 sides. So you will be having A1, A2, A3, etc., etc., etc. Finally up to A14, A4. So all of them will form a regular polygon like this. So this is a regular polygon of 14 sides. See, all lengths are what? Equal. This is A0. This is A1. This is A2. So at any point here, let us say this is AK plus 1, this is AK. Mod of AK plus 1 minus AK is nothing but what? Side length. Side length is it not? Mod of AK plus 1 minus AK is side length. Yes, understood? So, what is your numerator? Numerator is equal to sigma k is equal to 1 to this side length is A, let us say, is A, which is 12A. Understood? We got like this. Now, similarly, when you observe this, when you observe that, they are also, this is also side length of some side. See here, AK plus 1, A 4k minus 1. Suppose let us say k is equal to 1 you got. K is equal to 1 means it is as good as what? A3 minus A1. Which is nothing but what? A3 minus A1. So, sorry, k is equal to 1 means you are going to get A3 minus A2. A3 minus A2 is nothing but what? Side length only. See, this is k is equal to 1 means A2 minus A1 side length, A3 minus A2 side length. So this is also what? Side length only. K is equal to 1 means you are going to get A3 minus A2 side length. K is equal to 2 means what you will get? 8 minus 1, 7. A7 minus A6 side length. So k is equal to 3. One more side length. So your denominator sigma k is equal to 1 to 3 is also side length, which is how much for you? 3a. So what is your answer now? 12a by 3a, which is equal to 4. That's it. So you should identify that each term is a side length for you. Like that, how many terms? 12 terms. So 12a. Here also each term is a side length. For example, you put k is equal to 1, you will get how much? A3 minus A2 side length, mod of that. A3 minus A2 is a side length, k is equal to 2, you put it. You will get A7 minus A6 mods, that is also side length. Side length between the vertices 7 and 6. All side lengths are what? Equal. So that's why each side length is A, let us say. Then numerator is 12a, denominator is 3a, therefore the answer is how much for you? 4 for that problem. Now the next question is z is equal to cos theta plus I sin theta, theta is 2 degrees. Sigma k is equal to 1 to 15, imaginary part of z power 2k minus 1. See, z power 2k minus 1 is cos of 2k minus 1 theta, I sin 2k minus 1 theta. Correct? Z power 2k minus 1 is this. Imaginary part of z power 2k minus 1 is 2k minus sine of 2k minus 1 theta. Sigma k is equal to 1 to 15 sine of 2k minus 1 theta is equal to sine theta, sine of 3 theta, sine of 5 theta, finally sine of how much? 29 theta. You recall this result, sine A plus h, sine of A plus 2h up to n terms, sine of A plus n minus 1 into h is equal to sine of A plus n minus 1 into h by 2 sine nh by 2 by sine h by 2. In trigonometry last year I got this result, you recall this? So like this, sine of A is how much? Theta. How many terms? 15 terms. N is 15. 15 minus 1. What is h value? 3 theta minus theta is 2 theta. 2 theta is your h value. H by 2 means theta. Sine of nh. nh by 2. nh by 2 means 15 theta. By sine of theta. You got like this. So this is nothing but it is 14 plus 1 15. So sine 15 theta, sine 15 theta by sine theta. So this is sine squared 30 by sine 2 because theta is equal to 2 degrees. Now sine squared 30 is how much for you? 1 by 4 sine 2. Yes, understood? So z power 2k minus 1 will get like this. Imaginary part of z power 2k minus 1 is this. You put it here, you range your k values, you will get the sine series like this. You are expected to remember this result which we taught in first year. Sin A plus h plus sin A plus 2h sin of A plus n minus 1 into h is equal to sin of A plus n minus 1 into h by 2 into sin nh by 2 by sin h by 2. A happens to be theta for you. A is theta for you. H is 2 theta for you. So A plus n minus, n is 15 terms. N minus 1 into h by 2 is theta. Sin nh by 2. N is 15 theta by sin theta. So this is sin 15 theta, sin 15 theta, sin squared 30. Sin squared 30 happens to be, because theta is 2 degrees, therefore you will get 1 by 4 sin 2 degrees. That's it.